Okay, so I'm Marton. I'm from Romania, and I'm on Stack Overflow with a great reputation point where I answer a lot of questions for you. Today, I'm here to show you about cloud platform essentials. On my presentation today, you won't see CI, DI, and anything which is the build platform run. I'm here to actually present you a bit of architecture and how DevOps engineers can take out more information from all of the platforms and all of the interconnecting systems in the platform. We will talk today about a bit App Engine, one of the great products from the GCP. We see Cloud Functions, Stackdriver, BigQuery, and all these will be from our experiences, how we develop software in Red and we do actually hybrid clouds. Like we do a lot of application in-house, but we need to do externalize certain services on different cloud platforms. Let's see what's hard about traditional app development. As you see, there are like 20 components usually when you start to developing applications, but nowadays it resumes to address capacity requirements. And that's actually when you turn to the cloud. If you have a certain application where you are a hosting platform for blog posts or blog platforms, you may run 600 websites on a web server. But if you develop larger platforms, then you need to turn into the cloud to actually build it right. So application development isn't application development anymore. It's more like choosing the right tools and mixing these tools for the business value. At Red we use GCP. I want to do a quick study in the room. Who uses AWS, Azure, GCP, and who is not using cloud at all? Oh, great. So thank you for this. The GCP platform is a constant is in constant evolution. And if I would put here slides, it would be actually 4 slides and it would be updated every week. I've just put here 2 slides and just to showcase you that how many platforms there is. I will talk about mostly about BigQuery and eventually from here the cloud functions and how this federated ecosystem is working together to actually address certain DevOps problems. On the next slide, it is continuing. I don't want to spend time. The management tools with the Stackdriver and monitoring is something that I really like, and I will show from this only the hidden features. So it won't be a general presentation for that, only the specific value that we actually use and turn out a good value for us. So let's see how Google likes to think of serverless compute as a set of capabilities here in a term of 3 axes like development, ops, and the billing model. And I want to showcase you that on Google, like the principle is that automatic scaling is also means scaling to 0. Even app engines can scale to 0, and even Kubernetes can scale to 0. I mean the pods, the master is there, but that's offered in the ecosystem. If we go further and we develop the serverless thinking and this new thinking, you will see that first of all we need an event router. Eventually, we need an event router, which is on the GCP platform, the Dataflow. And on the Dataflow, we may, first of all, when we touched with the GCP platform, we use the BigQuery as a storage. But there is Cloud Functions, which interconnects a lot of input and output, and App Engine is a quick way to actually address the HTTP needs, for example, for a function. But also there is PubSub and also there is scheduling tasks as well. Meet serverless. So serverless, it's not depicted as a warehouse where there are no servers. Actually, there are servers, but the operation and the maintenance is hidden for you, and you have automatic scaling, and you only pay for what you use. And from here, you have this event-driven concept. So if we need to give a definition to serverless, we will see that it's about maximizing elasticity, cost savings, and agility of cloud computing. The agility part is actually where it helps me, because I develop software for like 10 years and always I have old projects where I need to constantly support, add additional functionality. But when you have a stack which is at least 5 years old, that's a boring stuff to update, and I need to add fun stuff. And nowadays I'm able to add fun stuff by going out with this serverless thing, and certain aspects of the project is being developed on the cloud. When we are talking about the types, we see that there are platforms and there is triggered code. The platform side is also the managed world, like what's managed for you, and the operation is actually hidden for you. Here we have App Engine, one of the core products of the GCP platform. It's best used for HTTP services and for existing applications. And the App Engine, if you want to take on a infrastructure diagram, you will see that I have added here the modern versions as well. With the cloud balancing, App Engine is one, but you may use VM instances as well. But nowadays there is the Kubernetes services. So this is a bit of history, that first people deployed software without renting a VM, then eventually they wanted to do something custom. They go to the VM, and nowadays they actually go into the Kubernetes system. The App Engine, what we like and what we use for, is that actually allows us to do this A/B testing, and based on services and different versions and instances. We are able to test out quickly the version, for example, of a deploy, where you're actually changing an interface, A/B testing. We have 2 different versions for this. We can even test out different machine types. Like I have 20% only of my traffic of the existing code on a higher machine. And I am able to actually have a cookie, the next slide. I am able to actually have a cookie where I actually said that some of my customers are being routed to a better machine, and some of the other customers are routed to a slower machine. You can actually leverage this information very nicely, because often you have like either you are heavy anonymous web visits, let's talk about web, or logged in users. And you can route this based on the cookie information to the same code. You can route to different machines and responding faster. Or you have a customer where you have a SaaS application, and where one of the customers is actually a higher use of the platform. You can set up a special cookie for that and actually route to different versions. So these kind of experiences I want to share with you from the general definition. You see here that this is the version number simplified. Like number 2 gets 90% and number 3 gets 10%. Of course, this is on an interface, but this can be tooled, and you can actually share and also roll back with different situations. So like we use with like 30 situations this kind of versioning in the App Engine system. App Engine is a managed service. These kind of languages you can develop on. They are constantly adding and improving the support for the modern languages. I want to do another quiz in the room. Who developed using message queues so far? Okay, thank you. Who using message queues with more than 1 million volume for a month? Thank you. 2 hands, 3 up. Thank you. Okay, you need to actually go further. Whenever we added message queues in our systems, actually we end up adding operation as well, but reducing latency. And by reducing latency, we got business value, and the operations actually are natural nowadays for us. I've just put here 2. I don't want to spend too much time on these services. And this is one of the entry points in the cloud where you actually do hybrid cloud. Like you have an application, but you want to do message queuing with the infrastructure on one of the cloud vendors. Usually the cloud vendors offers 1 million processing for free per month. And that, just thinking like 1 million requests are free on the queue systems, for example. The queue systems are different. There are push and pull queues, which HTTP nodes, or actually you wire in and you actually take out information from the queue as well. You can have different topics and priority and all on. If I want to actually add it to a diagram where the queues are, you see here that there is an application which has different services, from a front-end service to eventually dynamic content and some storage, and you have eventually caching also on the platform, but you also have the front-end placing messages on the queue and reducing latency. The queue system as a general concept can be represented like this, where you have like you put the message, gets into ready, reserved by a worker, and ready. But also you can put a delayed message, like only fire 2 minutes later, only fire 7 days later, and gets reserved and ready. Then if the reserve, it does something bad, times out, or it has an issue, you can actually turn it back and raise an event, raise an error, get an error, and so on. We use the bury section very frequently. I have a special presentation just on the elements of the queue system. By adding queue into the front-end application, we actually reduce latency. Often nowadays, if we talk about websites or front-end applications, there are usually lots of components, and usually you have like 1 second latency. But if you actually add just the queue message, that's like 25 milliseconds to it. Later in the background, you need to process it, but there you can actually optimize based on the volume, and actually you can auto scale down or up based on the volume. So for example, for us, sending an email campaign with millions of volume is not a problem, because it can actually scale up with the queue system. Or when the user signs up or does an order on a website, there are certain processes like temp process, even generate a PDF, send invoice, email, and everything that's placed in the queue system. The other benefit of this is that we can add tasks for the junior developers. The junior developer is actually just getting the task, hey, I need to develop this single task, and that's it. The overall implication of that is the team leaders or the architect objectives. Let's go next to cloud functions. I want to do another quiz in the room. Who implemented whatever Lambda function, serverless function in any other cloud? Okay, thank you. Who does this on a platform in-house? Okay, no. You may have seen the Knative presentation, and you will see eventually launching in Google Cloud Next services for this kind of global entry. So cloud functions, if you go back to the generics, the functions include like confirming a purchase, an account creation, or a password reset. It can be a thumbnails upload, like automatically blurring the gore of an image, or it can be machine learning analysis of a comment, like if it contains vulgar words or similar events. Even on IoT systems can be leveraged. And it's a triggered code. So there is an input and the code does something. If you want to go this more generic, it's a unit of computing like a function, not as a platform, not as a code. And it's a single purpose microservice. If you go further, you will see that this is always event-driven, and it actually connects and extends all the services. You can, on Google Cloud Platform, use these languages to develop the functions. And what we like further is that there is here 1 million accesses every month free. So for example, if you have just a simple project, you may try out different vendors and actually play with the cloud functions, and you will see the low latency and so on. Cloud function is a gateway to the GCP services. Google does this extremely great by connecting many services, hundreds of APIs, and I would say that, for example, you may see that outstanding here that there is the dialog flow, actually Google Assistant represented here, which you can develop application for the Google Apps, Google Assistant, And you may know that Google Assistant has a general part, like asking what's the capital of a country, but also has the application part, like I want to talk to cinema app, I want to talk to the energy provider app, I want to talk with I don't know, the airline travel app and so on, and you can actually naturally converse with these applications. When you end up working on an integration, because you may have your projects going to the chatbots world, you will end up in the GCP platform working with Google Assistant and actually Cloud Functions to actually return for the assistant customized response for that. You will see here that the BigQuery pops up, storage, and everything is added here, but I will go further with the screen where I will lay out different events what the Cloud Functions get. And here with kind of story and like that. So what we leverage first is that we put files on the cloud. Lots of people are still using S3, but there are other solutions as well. On GCP, when we add a file to the storage, we get the finalize event. It's when the file is there, even if it's an image, we need to build thumbnail. Eventually, we can fire a Cloud Function to build a thumbnail. Or if it's a CSV file, let's say, we need to import into the database. We can do several additional tasks with this. It's extremely easy to do. The code is just like fits on the screen, let's say like that. Then, compute engine. There is the spot requests terminology, and there is preemptible on GCP for running VMs, which runs maximum time 4 hours, and it has I don't know, like 30% of the real machine costs. What we use here, we use even the instance and the autoscaler functionality of our nodes. Like for example, if we have Elasticsearch with 5 nodes, we can have like 3 permanent nodes and 2 running on preemptible. And leveraging the Cloud Functions emit events, we can actually see when the instances go down, I mean those 2 which are preemptible, and when they come back. And these we can actually automate Elasticsearch to lock the reallocation or to open up the reallocation, or actually to automate which how it's called which nodes gets rebalanced and so on the Elasticsearch service. Also firewall. Nowadays people tend to ignore automation of firewall. So whenever you add a new instance into your cluster, you may run a check on that instance that it's actually included in the firewall system. And whenever you boots up, you get an event, you can actually ping an external service, try the server to break it, or test the server if it's actually closed by the firewall. And labels. Labels is actually one of the great systems in the GCP platform. Whenever you can attach label, it will actually propagate to all of the subsystems. The logs contain the label, the BigQuery federated data source contains the label. You can react on these labels, and you can actually use the labeling service. Like we have code where the label is actually the folder in our code organization. Like whenever this is the HTTP label, we do the respective task on the all the cluster, even if it's a Cloud Function, even if it's an app engine and a firewall change. The next screen actually uses the Firebase, the BigQuery, and the Firestore event. If you develop mobile applications, you may have used Firebase. There you already use the real-time DB chains. Like whenever there is a new topic, you announce, like with push notifications about the updates. And on the BigQuery, there is the job create and the job complete, which is an amazing tool. Like whenever you run a query, when it finishes, you can pick it up. Sorry if I rush it. It was the first part of the presentation, and I wanted to actually quick go over on this. So if we need to summarize, I actually added information of our experience on the typically exposed HTTP services and the auto scaling, and actually the unit of computing is yours to choose here. On top of this, which I don't go into, is the serverless add-on. there will be announcements in CloudNext. CloudNext is a conference in California, in San Francisco, in like 3 weeks. There will be a bunch of announcements on this continuity for the Kubernetes platform. And as it sums it, so it's a slice and dice, and it can add more agile to your application, better apps, and deliver value. Okay, let's talk about a bit monitoring. On the monitoring, there is a constant debate. I've seen here like 6 presentations so far about monitoring. In-house, hosted, the data is scripted, not crypted. Is it modern? Is it proven? Specialized, general, paid versus free. So we can actually spend the whole day debating all this. But as a developer, for me, I want it to be quick. Like, I don't have time. I have a small environment. I don't want to spend like 3 days to set up all the monitoring and so on. And I want to do on other things as well. And others are getting used to this. And that's it, Google Stackdriver. Google Stackdriver is a service where it's intelligent, it has machine learning capabilities to actually put on your screen something that they observe. The management for services, containers, applications, and infrastructure as well. And here I want to emphasize that this is hybrid. So there are those components with the agent and the monitoring which you need to put on your instances, but those can be added on-prem, can be added on AVS. They even have a blog post explaining like 10 lines what you need to add to the AVS instances, and you can actually add the information to that. Someone yesterday asked on one of the talks, like, is there a solution which tries to come together all these cloud vendors? It starts to shape. Maybe there are others, but it's starting to shape here. And my favorites are actually the last two. The debugger, error reporting, and the profiler. It's non-charged. That's what I mean with the free. I'm able to actually get the code from our Bitbucket. It doesn't need to be in the GCP. And I can add the debug entry on the code itself. And it will automatically, with the agent which is installed on the machine itself, automatically hook into the platform and actually do these things. And the uptime checks, which will be next. The uptime checks is Pingdom, similar, or the other vendors out there. And on the GCP, this platform is actually free of charge. And this is one of the hidden features with every developer which I end up discussing starts to use it, because you can actually add here thousands of entries. You can build out your own endpoints, returning either a number, either a status code, which represents how it goes. And of course, you get email, SMS, Slack, whatever webhooks you are setting up there. Also, it has custom headers which are encrypted, which is great to actually set up that your deepest service latency can be actually measured by the Stackdriver. The Stackdriver naturally uses all the cloud regions of the GCP platform, and you are able to actually see out how your application is performing in different parts of the world. Life of a log. I just put here to represent that in the cloud, and generally speaking in the cloud, usually when you access the API, that API has a hook system and does duplicate the data also to other subsystems. And this is where actually I say that metrics, logging, alerting are a universal right for you. I don't want to actually build tools around this. I want to have my data available in different subsystems and consume where I'm actually friendly to consume, either on the interface, either in the database, or either as a raw data. And when I'm talking about raw data, I need to mention BigQuery. I will do a quick quiz. Who is using BigQuery in the room? Great. Google BigQuery is one of the hidden treasures in the cloud vendor system. Like, there is nothing else in the cloud vendor. It's one of the greatest services. And sorry to be like sales here, but when I found out that BigQuery charges only 20 for the terabyte of storage and only 5 for the queries, I actually had projects where BigQuery was having, I had on the billing like $20, $100, and so on. I have one project where we have in the petabytes the data storage, and there we have $20,000 on the bill itself. It's an analytics in the service, it's full SQL, it's big everything, and my favorite is that I can create up to the 5 terabyte of CSV files, so actually I can dump all our database as a column and put it on BigQuery. The other is that it has a modern SQL language, which all the window functions and everything which is in the 2011 standard. And my favorite is that the user-defined functions can be written in the JavaScript. And by JavaScript, I can inline a lot of things like natural language processing in the SQL language. And this is something amazing because I have the command from a blog post, and I can analyze with the natural languages with using just SQL on a large database. And now the hybrid part. Whenever I have an application, in order to go into BigQuery, I need to use the ETL engine. And this ETL engine is something that we need to choose wise. As BigQuery has another big life, let's say, like a big life, this is called federated data access. And by federated data access means that everything in the GCP platform can be grouped together and can be integrated in the BigQuery section. What it means here, like we have audit logs, for example, this one, audit logs. Audit logs are the natural information from the cloud. Even if I run an instance, even if I log a log, even if it's billing information, those informations are actually automatically put into the BigQuery raw data. From there, I can analyze it. I can actually end up like one specific customer has a SaaS customer has a special functionality. I can actually label that functionality, and I can do queries like this is the how many cloud functions they are using, how many instance hours they are using, how many auto scaling operations do I need to do in order to satisfy the latency of the customer. And this is, I say that this is DevOps because I have the information in BigQuery which I can extract from the system. And apart from that, there are some Google Analytics information. Like whenever I found out that I can mix business reports with Google Analytics with SQL queries, that was one of my favorite days. And Google Analytics doesn't have the person. It only has the information, like of a request. But then I can attach with the business database, and I can actually merge together with the business value for that. On top of that, BigQuery added last year machine learning. You should Google it up. That should be a separate session, for example. We can create logistic models just using SQL language. It's not create table, it's create model, and you describe the information, you train it, and when you evaluate it, the evaluate is actually a select on the table. And the select is returning that number, which is the precision for you. It's returning from 0 to 1. And you can quickly actually flag something out by running select statements, for example, on your event data or on your log data and so on. So let's try to group this together. I was mentioning that I'm doing hybrid cloud. And when I do a hybrid cloud, the first process is that I need to move the data. And whenever I move the data, it's either stream-based, either batch-based. And if I want to choose the GCP solution, that's the Dataflow. For this demo, you should Google up Dataflow Tram Challenge. There is Graham Pulley from Sydney, who actually in 18 minutes of a ride on a tram processed billions of results just using the laptop and the browser. And there you will be amazed by the service itself. Okay, we have our app outside of GCP, how we can use the benefits of BigQuery. We can actually, at Reanet, we implemented a tooling which looks the following. So we have all our event streamings, routed to a fluentd open source component. And open source component means that it has a plugin system where actually I can wire in Google Cloud Storage as an archive process. I can send directly to BigQuery, and I can forward later to my application as well. And I can add different services. We archive all of the details to the cloud platform because there will be one day where I need to replay it. I usually tend to add now a lot of data into my events, like all the business and all the variables I have, even if I don't use it. That information is stored actually in BigQuery, but also as a file on the cloud storage. And whenever I eventually didn't do a column for all the information, but it's present in the log, I can replay it and add that information into our warehouse systems. Of course, this concludes with running data reports, and there Tableau quickly, and actually all the connecting services have interfaces with BigQuery. So even data analysts, without writing reports, they can build out different reports for them. So it mixes also operational events, logs, and business value for the systems as well. fluentd, I will go quickly on this because we are short on the time. So on the fluentd, there are actually 4 processes on my example. Sometimes we need to transform a record, which is described as a record transformer, and here we can actually, the transform means that we duplicate the data, we clone the data, and we add sub plugins in order to actually do a subtype of file and a subtype of BigQuery for this. The other is that there are options to actually add code for it, like we need to add certain insert IDs, or we need to remove certain values with overwriting the value, or we can add out calculations on the AVG averages and so on. This is just setting the file path format, and this is setting up BigQuery, how it works, connecting what table to use, what information. My favorite from here is ignore unknown values. Whenever the BigQuery doesn't have the necessary columns, there is a feature that all the additional information is wired into a JSON, and that JSON is there as a column. I always have in my tables a meta column, which is a JSON information, and whenever I need something materialized from the JSON, I can turn that back into the column for this. So our benefits. It's actually a big data tool, but in order to go into the big data, we need to do more data, to collect more data, and we need to actually leverage it with a language that we know. It's SQL 2011, it goes great. It has all the JSON capabilities, functions, like I can store JSON content in the database, and I can pick out from the JSON like it was a natural column. And there are additional cost savings operation for partitioning, clustering. So I have 6 dimensions, 1 partitioning and 5 clustering fields in order to reduce our larger table to a query for ads. Analysts can run queries by using their tools. They don't coming to the developers that hey, let's build out a report for us. You should try first your tooling. If the report is satisfying you, then we can turn it into a permanent solution for that. We throw in all kind of junk data for that. So whenever, for example, a junior programmer asks, what should I put in the log? Whatever you have available, but that won't be a problem on the billing. No, because BigQuery is cheap for that, and it's exactly for that. So we added additional information for that. You can try out at home. There is a sandbox. It offers 1 terabyte of free. The entire Reddit, Stack Overflow, GitHub, open source information is available for query without any problems. You can, for example, find out how many GitHub repositories use your plugins if you develop plugins, sort on. We don't have any focus on large scale execution plan, and we don't run out of resources using the managed services. And if you go home, if you want to do trainings, and there is this quick labs where you can actually find out interesting tutorials. Usually these take 40 minutes or 1 hour. There are different topics as well. I put some of the most important one. There are the Kubernetes nowadays. People are taking Kubernetes, the machine learning, and there is this architecture information, because companies nowadays tend to send a lot of people for certification on different architect platform as well. There are Quick Labs credits, so this is a paid platform, but you should check out meetups and additional webinars where you watch the webinar and you are able to get Quick Labs credits. And that concludes my talk for today.